Now, continuing with the mechanisms of nucleophilic substitution reactions, the second type which we'll be talking about is the Sn1 mechanism, right? In this Sn1, this S stands for substitution. The primary type of organic reactions we are dealing with are substitution reactions. किस चीज़ का substitution? Nucleophile. Weaker nucleophile is substituted, is replaced by a stronger nucleophile, and 1 stands for unimolecular in Sn1 mechanism. हम example करेंगे and you'll see that these reactions, the reactions which follow Sn1 mechanism, they also follow first order kinetics, right? So because of these properties of this mechanism, there is this name Sn1, unimolecular nucleophilic substitution. We'll try to understand the mechanism by taking an example. And in this case, we'll be taking the example of a tertiary alkyl halide. I'll take tertiary butyl bromide, right? The halogen atom here is bromine, and we'll be taking the same nucleophile which we took in Sn2 mechanism, OH negative. The product formed here is CH3, C, CH3, CH3, CH3OH plus Br negative, right? Now this is the incoming nucleophile which is stronger, and this is the leaving group, or we call it the outgoing nucleophile which is weaker. That is why OH negative is able to substitute it in case of this compound. Let's talk about the mechanism. This is the product. You start with alkyl halide and you get an alcohol. But how did we reach there? Let's take a look at the whole mechanism. Now, as far as Sn1 mechanism is concerned, it takes place in 2 steps. Step number 1 is we have CH3, C, CH3, CH3, Br. Now this CBr bond is a polar bond, right? Obviously the electron pair is more towards the halogen atom. What happens here, there's a complete ionization, right? It is not just that you have a delta positive somewhere and you have a delta negative here. There's complete ionization, and also this step is a slow step. What we get here is we have carbon here, CH3, CH3, CH3. Now as you can see, Br leaves along with the electron pair. When it leaves along with the pair, what is left behind is carbon with positive charge, and such a species is called as a carbocation. Now this is not a transition state, it is a proper intermediate formed in the middle of the reaction. It is stable, it can be isolated. This is the first step. Now since it's a first step, it is a slow step, it has been seen that the rate of the reaction is proportional only to the concentration of CH3 whole 3 CBr, right? Unimolecular, therefore it follows the first order kinetics. It's dependent on the concentration of only one reactant, which is tertiary butyl bromide in this case. Now in the second case, what happens, we have this carbocation, CH3, 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 and our incoming nucleophile OH negative. It is negative, it will attack the electron deficient site. It's a fast step. It is compulsory to write down to know that which step is slow, which is fast. Then only you can decide whether the reaction follows first order kinetics or second order kinetics or whatever. The product is CH3, C, CH3, CH3, OH, alcohol, right? Take a look at the complete reaction. This will be our step 2. So first thing which you learn about Sn1 mechanism is that it's not a concerted mechanism. It takes place in multiple steps. It takes place in 2 steps. In the first one, the leaving nucleophile leaving behind a carbocation. A carbocation is always formed in Sn1 mechanism. And in the second step, that carbocation is attacked by the incoming stronger nucleophile so that the product is formed. In this case, it's a tertiary butyl alcohol. As you can see, number 1, it follows first order kinetics, thus unimolecular nucleophilic substitution. Number 2, there is no inversion of configuration. Br reactant may be on the right hand side tha, OH is on the right hand side. There is no inversion of configuration here, right? Now order kya hoga? Which alkyl halides show this Sn1 mechanism? Which alkyl halides undergo nucleophilic substitution via Sn1 mechanism? It primarily depends on the stability of the carbocation, stability of the intermediate. यहाँ पे वो intermediate क्या है? It is carbocation. Stronger the carbocation, more feasible is the mechanism. And carbocations के बारे में आपने class 11th में पढ़ा है. We already know that 3-degree carbocation is the most stable carbocation, more stable than 2-degree carbocation, which is more stable than primary carbocation, which is more stable than CH3+, right? Therefore, for Sn1 mechanism, अगर आपको order of stability, order of feasibility decide करना हो, Sn1 mechanism is the most feasible in 3-degree alkyl halides. Because जब 3-degree alkyl halides आप start करोगे, it will lead to the formation of the most stable carbocation, the tertiary carbocation. After that, next in order will be 2-degree alkyl halides. Next in order will be primary alkyl halides. And last in this order will be methyl halides. Now as you can see, you can draw the comparison between Sn1 and Sn2. The order is completely reverse. In Sn2, methyl halides में सबसे ज़्यादा possibility होती है Sn2 mechanism की, whereas tertiary alkyl halides में सबसे ज़्यादा possibility होती है Sn1 mechanism की. Right? These are the 2 types of nucleophilic substitution reactions which can take place in haloalkanes, Sn2 and Sn1 mechanism.